If you have a quartz watch, it might lose half a second every day. Half a second seems trivial in our everyday life. We do not even think about it. But if you are walking with precise positioning, then 1 microsecond or 1 millionth of a second can deviate your position by 300 meters. Our precise position comes from the satellite into our GPS devices. And they have an atomic clock to make sure that this time deviation does not happen. What most of us do not know that these atomic clocks on the satellite that are moving in the orbit at about 14,000 km an hour can deviate a lot than the atomic clocks that are on Earth. But how does the time deviates in a satellite? Let's say you are standing at a railway crossing and a train is passing by you at constant speed. A passenger inside the train is playing with a ping-pong ball bouncing between two boards. From the passenger's perspective, the ball is moving straight up and down as she, the ball and the boards moving forward at a constant speed. From your perspective, the ball is not moving up and down, but the path of the ball is taking a triangular shape as it travels between the boards. From the passenger's perspective, the ball is moving a short, straight distance and it takes about a second to travel. But from your perspective, the ball is traveling longer distance. So if the time between the bounce remains same, to travel a long distance, the ball has to speed up, right? Let's assume that in place of the ping pong ball, it is a beam of light bouncing between two mirrors. From the passenger's perspective, nothing changes. The beam of light travels back and forth in shortest distance possible. But from your perspective, the beam of light is taking longer distance to travel. So do you think the speed of light has to increase to catch up with the moving mirrors? We know that the speed of light is constant for all observers. So to keep the equation distance is equal to speed multiplied by time, we must make the time go slow. Moving time runs slower than the stationary time. The time did pass at a different rate for the passenger than it passed for you as an observer standing stationary. Einstein's theory suggests that there is no such thing as absolute time. Now the passenger on the train and you as an observer will not notice this time difference because the amount by which time slowed down for the passenger was minuscule as the speed of the train is very small compared to the speed of light. But if you see a satellite moving in space at 14,000 km per hour and you compare the time on the satellite with your time standing on Earth, the difference becomes obvious. Every day the atomic clocks on the satellite slows down by 7 microseconds, and this is called Einstein's special relativity. Next time you want to buy a high quality Swiss mechanical watch, remember that watch will deviate plus minus 5 seconds every day. Cheap quartz watches, they maintain a better time. Contribute to my effort to bring you better videos by subscribing to this channel and sharing this video with your friends. If you want to be the part of my community, then you can join my channel as a member. Keep asking questions and always be curious.